What's up guys, welcome back to my channel, and in this video I'm going to help you kickstart your game engine by helping you develop the mathematics engine. So without further ado, let's roll it. Hey guys, I'm Hero Serrano, and if you are new to my channel, welcome. I'm here on YouTube basically sharing everything that I know about game engine development so that you can develop your own. So one of the things that many people have asked me is the following. Basically, their question starts out by saying that they want to develop their own game engine, but they do not know where to start, what system to implement, what to implement first, on and on. And my answer has always been the same. Well, if you are planning to develop a game engine from scratch, the first thing that you need to do is develop the mathematics engine, more specifically implement linear algebra operations. Why? Well, basically because in a game, 80% to 90% of the math that is involved is all about linear algebra. It's all about transformations, vector transformations, space transformations, etc. So if you do not remember anything that you learned in college about linear algebra, I suggest you to review it. And if you are completely new, you have to learn it. And there's this really good book that will serve both people basically, and it's this book called 3D Math Primer. I strongly recommend it because, guys, this was the book that helped me develop my own game engine. Not only will it teach you the theory, but it will also give you the source code that you can use as a reference. So I strongly recommend it. So again, why do we need to develop the math engine first? Why? Well, basically, again, it's because it is the math that it is used in games. But I think it will help you, bring down the idea that you have to do this by with a simple example. So whenever you play a video game, right, on your PlayStation and you move the joystick, right, have you ever wondered what's going on when you do that? Basically, when you move the joystick to either rotate the character or to translate the character, you are manipulating matrices. And let me explain how that works. A 3D model, game character is made up of many vertices, all right? And these vertices are defined in a particular space. And that space is represented mathematically through, with a matrix, a 4x4 matrix, right? This 4x4 matrix holds the information that is required, right? It holds information about the orientation of the character, and information about the position of the character. For example, the 3x3 matrix that I'm highlighting holds the orientation information, and the column, this vector right here, holds the information related to the location. This is what the GPU uses to properly position the character on the screen, right? But this is only half of the story, right? Because after actually, let me go back because I forgot to tell you something. So basically, when you move the joystick, right, to rotate or to move, you are basically manipulating those values, the values in that matrix, right? And what happens after that is this particular space that represents the model space, the character space, gets transformed by other spaces. For example, it goes from the model space to the world space, and then to the camera space, and then it gets transformed by the model view projection space. And ultimately, it shows up on the screen, right, where you start, you're playing and whatever, right? But basically, that's what happens, and whenever you move a character. And as you can see, there's a lot of operations involved in here, right? Number one, we are basically transforming vertices, right, from one space to the other. We're also translating vertices, and we are also transforming spaces, right, from model space to world space, on and on and on. All right, so this should give you an idea on what to implement in your mathematics engine. The first two classes that you need to implement are going to be the vector class and the matrix class. But now, what operations should you work on? Well, when it comes to vectors, the ones that I recommend you to work on first would be to implement the addition operation, subtraction operation, and the dot and the cross product. Those are very handy operations that you are going to use quite often, especially the dot product. And when it comes to the matrix, the operations that I would implement would be the vector transformation and the space transformations, right? You do not have to implement other operations related to matrices and or vectors. You will have to do them eventually, but in the beginning, you don't have to worry about that. So just focus on these operations. All right. So let's go over some of this. I'm going to give you some tips, all right? So that way you know what to do and what not to do when you are developing your own mathematics engine. All right, number one, and I'm going to be using my game engine as a reference, so that way I can share with you the tips that I want to talk about. Number one is that do not forget to declare your classes within a namespace, all right? For example, here in line 1, I have declared the namespace for my engine, which is U for the engine. And the class U for the vector is basically part of that namespace. You want to do this. Why? Because you will most likely import another library to use along with your game engine. And if that particular library also uses the same method name as a class in your game engine, there will be conflict and chaos, and you don't want to spend time debugging that. So if you have not done so, please declare a namespace for your engine. It could be whatever name you want it to be. And if you're starting, make sure to implement this right away, right? Now, here I'm showing you my class U for the vector 3n, which is basically a 3D vector, a vector that deals with 3 components, x, y, and z. And one thing that you will notice is right away that my components, the x and y, z components, I have not declared them as private, but instead I declare them as public. Now, I know that if you pick up any object-oriented programming book, they will suggest you to declare your data members as private so that you can use setters and getters. Now, that is great, but guess what? Rules are meant to be broken only if you know why they were established in the first place, all right? In this case, in this instance, you do not want to use setters or getters in your math engine. Why? Because if you do so, things will become very cumbersome and very chaotic very soon, especially when you implement the physics and the collision detection system. You're going to be doing some very complex operations, and using getters and setters, it's just going to look like a mess. So don't do that. So let me give you a quick example here so you can see what I mean. Here, for example, let's say that you want to add the components x and y, right? You have ignore my advice and have used setters and getters. Fine, right? If you wanted to add those 2 components, you will have to call get x and then the function get y, and then you have to add those 2, and then whatever value you got, you need to use set z because you are using setters. Again, you didn't listen to me, and you can see how that's going to look like a mess very soon. However, if you do not use setters and getters and declare your data members public, if you want to add to the components, you just have to add x plus y is equals to z, and that is it. That makes things a lot clearer, a lot better to work with. All right. Now, that's one thing that you need to keep in mind. Use namespace, declare one, and make sure to set the data members as publics. All right. Now, As I mentioned, the vector class should have several other operations, right? Such as addition, subtraction, scalar multiplication, on and on. Now, one thing I will recommend you to do, and this is for the sake of simplicity and readability, is to overload the operators, right? For example, here the two operations that I'm showing you, they basically add the vectors together, right? But I have overloaded the operators, the plus and equal sign here and the plus sign over here. Now, this is not necessary, but it will make your game engine a lot nicer to use, right? And easier for you to also work with, right? For example, let's say that I want to add two vectors, v1 and v2, as I'm showing you right here, right? If I want to add these two vectors and I did not overload the operators, right, I would have to actually call a method called add in this example, where I would have to add, v1 dot add v2 and then get the value over here, right? Now, if you would overload the operators, things become a lot nicer, because all what you have to do is just call, just say v1 plus v2 is equals to v3, and that's a lot better than having to do the add. Now, when you have a simple problem like this, you don't appreciate the benefits of overloading an operator. But when you are working on the physics and the collision detection system, you will have to deal with some complex operations, and that is when you will want to that's when you will benefit from overloading the operators, right? Here, I just made up this example so that you can see how easy it is to work. Now, imagine if I wouldn't have overloaded those operators. I would have to, not good. All right. So next one. Aside from the addition, subtraction for vectors, two other operations that you're going to use a lot are the dot product and the cross product, especially the dot product. You have no idea how many times I have used that operation. It is very handy. And again, you can see here that the dot product, I overloaded the operator, and I did the same thing for the cross product. All right. So when it comes to vectors, just focus on those operations and, follow my advice. Now, when it comes to the matrix class, again, as I'm showing you here, I'm using the namespace, and as you can see, I have also made sure that my data members, my matrix data members, are public, right? Again, for the same reason as I explained earlier, right? And the operations that you want to implement in your matrix are going to be basically related to vectors transformations and space transformations that I'm showing you here. Again, here I have overloaded the operators except for this one. Again, it's up to you how you want to do this. I tend to use a lot of, I overload the operators quite a lot. Because I like to just multiply a vector by a matrix. All right, guys. So that is basically the main two classes that you need to implement, and the operations that should be enough for you to see your character show up on the screen. You are not going to be able to do much with it. All right. There's more ahead, right, that you have to work on, that you have to implement. But this will be enough for you to actually get something on the screen, right? And so again, this is the book that I recommend you to get, the 3D Math Primer book. It is a really good book. I'm going to provide the description in the description below, so check it out. And now I'm going to give you a tip that I want you to keep in mind, right? Do not use quaternions or dual quaternions when you are starting out developing your game engine. Please do not do that. I did this mistake. I went against the current. I shouldn't have done this, but I did it anyways, and I learned my lesson. So that you have a good idea of what quaternions are. It's basically the most simplest term. They hold the orientation information of the space. All right. And dual quaternions, they actually hold both the orientation and the position information. All right. That's the most simplest term. So please, if you're going to write a comment telling me, no, that's not it, I know I'm just trying to explain this to people who are new to game engine development. All right. And I don't want to get into that detail. So relax. All right. So now, do not use quaternions, do not implement quaternions or dual quaternions, right? Again, why? Because in the end, before you send the information to the GPU, you will have to convert that dual quaternion data back to matrix format, right? And I didn't know that at that time, right? So I literally spent so much time learning them, understanding them, and then implementing them, only to realize that by the time I had to send the data to the GPU, I had to convert the data back to matrix format. And in my engine, right, I have to use this method right here to do so. I basically based my whole game engine on dual quaternions. Yes, I do use vectors and matrices. I do use them, but most the transformations, space transformations, are based on dual quaternions. So again, most of the work that I did on dual quaternions was kind of not necessary, right? So I want you to know that so you don't make the same mistake as I did. I'm not saying not to use quaternions in your game engine. No, you should use them because they have a lot of benefits, especially when it comes to dealing with the gimbal lag issue that is inherent when you work with matrices. But do not implement them as you are learning to develop your own game engine. Don't do that, all right? It will only hold you back and hold you, make the whole process a little bit more boring. So don't do that. All right, guys, this is it for this video. I hope you liked it. I hope you learned something. Do not forget to subscribe to my YouTube channel and also click the like button. And please join my Discord server. My plan for this year is to upload more videos like this where I share with you tips and tricks on how to develop a game engine. And let me know if you like this format. The other format that I was thinking of doing was to actually do some coding so that you can actually see me code a game engine from scratch so that you can follow along. But I do not know if that would be ideal. I really do not know. So let me know if you like this type of format better. All right, guys, thank you so much, and I'll see you next time.